Sir, am I audible, sir? Shall we start, sir?
Yes, sir. But one motivation session is there. I think I.
Sir, your voice is not audible.
Hello,
Yes, sir.
sir. There is one motivation session for first 5 to 6 minutes.
Yeah, okay, okay, sir.
Okay.
Okay, shall we start the recording?
Sir, no, sir.
Once motivation story over, and then we will start the recording.
No, sir. I got to tell that one teacher that is, I don't remember that name.
Oh,
Uh, please wait, sir, 1 second.
yeah, okay.
Miss Rajeshwari ma'am will take motivation session for 5 to 6 minutes before my class, and then
Okay.
I have to start.
Yeah,
So
okay.
Miss Rajeshwari is there?
No, sir.
No, sir. Okay.
Oh,
Then I will start my subject, sir.
yeah, okay, sir.
Okay, okay. Yeah, thanks. Good morning, student. Namaskaram. Today we are going to discuss one topic from 11th physics, chapter name thermodynamics. Topic name Carnot engine. This is one of that important 8 mark question. Okay. So we are diving into that fascinating world of heat engines. Already you are familiar with that heat engines. Yeah. The specially type of heat engine is called as it's known as Carnot engine. Okay. And this engine operates on a one cycle process. So this engine operates on one cycle process. One cycle means there are 4 stages included in that. We will discuss later. Okay. One cycle process. Okay. First of all, what is heat engine? Okay. What is heat engine? It is a device that takes heat, takes heat from a hot reservoir. Reservoir means it is a source. So this source have large amount of heat energy. Okay. It gives to that system. Okay. So the hot reservoir means it is a source of heat. Okay. So the device takes heat from the hot reservoir and converts into some useful work. Okay. So this is a simple definition for heat engine. It takes for 100 calorie or 100 joule, but it does not convert all the 100 joule into work. It converts nearly for example okay, converts only 60 percentage of that input heat, and 40 percentage of that heat leaves that system as a waste. Okay. So remaining heat into cold reservoir. Remaining heat goes into cold reservoir. The cold reservoir, which is opposite to the hot reservoir. Hot reservoir is at high temperature. Okay, is at high temperature. Cold reservoir means which is low temperature. So this reservoir, cold reservoir, always ready to absorb heat from the system because the cold reservoir is low temperature. Suppose one hot object conduct with the cold reservoir ready to take heat from that system. That system ready to give system. Okay, give heat to that this cold reservoir system. Okay, so cold reservoir, hot reservoir, and in between there is a working substance. It may be ideal gas or gas. Okay. So the remaining heat into cold reservoir. You may think like a steam engine. Already you are familiar with the steam engine. Yeah. In steam engine, it burns fuel. Yeah. That is hot reservoir. Generate steam. Okay. That pushes the piston. That is work done. And then releases a cooled steam. That is cold reservoir. So this is a basic principle behind that heat engine. Heat engine, it has hot reservoir, working substance, and cold reservoir. Hot reservoir, which is means gives heat. Cold reservoir, which is mean absorb heat from the system. And in between, there is a working substance. So when we compare with the steam engine, it burns fuel. Yeah, that is hot reservoir. Because of we need hot heat from that hot reservoir. That heat converts water into steam. That generates steam. That steam which is used to push the piston. So work is done. Okay, work is done. And releases the cooled steam. So this is cold reservoir. Okay, so this is all uh, concept of heat engine. Okay, then Carnot engine. Then Carnot engine. So Carnot engine is a special type of engine. Okay, special type of ideal engine. Special ideal engine. Why ideal is that, sir? Because this Carnot engine really does not occurs in our everyday life. It is a concept engine, ideal engine, because there is a disadvantage or drawbacks in the heat engine. Already I told you that heat engine does not fully converts that heat into work. It has drawbacks. Okay, so on that side Carnot, that scientists found that concept, that is Carnot. It is a conceptual engine. Carnot engine is a special type of engine, that is ideal engine. Okay, this means it operates under perfectly irreversible condition. Reversible condition. It operates, Carnot engine operates in a reversible condition, because heat engine does not work on the reversible condition. It is an irreversible process, but this is a reversible process. So reversible condition means no energy is lost to friction or some other inefficiency. Okay, or some other inefficiency. No heat, no energy is lost. So it is a theoretical concept, but incredibly useful for establishing the maximum possible efficiency for the any heat engine. Okay. That Carnot engine operates between two temperature. Operates between two temperature. So two temperature means hot and cold. Okay. But it is a reversible process. From hot to cold and cold to hot. So there is a reversible process. So Carnot engine operates on the Carnot cycle, which consists of four reversible processes. Carnot engine operates on a Carnot cycle, which consists of four reversible processes. What are the processes? First process, isothermal expansion. First process, that is step 1, isothermal expansion. So, isothermal expansion. Imagine a cylinder. This is a piston. Okay. This is piston. There's a air molecule inside this. Okay. You put that gas cylinder on that sink or source. Source means hot receiver. Okay. So which is at a high temperature. So heat is conduct into this cylinder. Yeah. Imagine a gas in a cylinder. It is called a gas cylinder. Okay. We place this cylinder in contact with our hot reservoir. Okay. You may call this a source or hot reservoir. Okay. Hot reservoir. So which is a temperature TH? TH means high temperature. In your book, it is denoted as T1. So T1 means it is at a high temperature. Okay. So what will happen next? The heat goes into this gas. Yeah. So the gas absorb heat. This is step 1. The gas absorbs heat. Correct. It is correct. Where it is heat from that heat for that gas, it is from reservoir, that is hot reservoir. Okay, the gas absorb heat from the reservoir. Okay, and then what will happen next? That gas expands. Yeah, once the gas absorb heat, by the heat the gas expands. Yeah, like that. Okay, so gas expands. So isothermal means expansion means already now you are familiar with that. Okay, expansion. Okay, what is means for isothermal? Yeah, so meaning constant temperature. Isothermal means constant temperature. So this process occurs at a constant temperature. So temperature, constant temperature means temperature does not change. Okay, it is always at TH. Okay, it was always at a TH. So this gas expands. As it expands, it does work on the piston. Yeah, that is pushing that piston. Right? Clear? Now you clear with that. Yeah. gas expands. That expands gas push the piston, because the expands means volume increases. Yeah, correct. Volume increases means, so the gas will occupy this place, but there is a piston. So all the gas molecule pushing that piston. So the piston goes like this. Now, okay, goes like this. Think of like a engine, take a some take a deep breath of heat and using that heat energy to move. Okay, so piston moves upwards. This is piston, that engine, piston moves upwards. It is now clear with that concept. Okay, right. Then next, adiabatic expansion. Adiabatic expansion. For this process, adiabatic expansion, that is stage 2. So for this stage 2, that is step 2, means once a cylinder gets absorb heat from the source, and then take this cylinder into, this is insulator, okay, insulating stand or insulator, insulating stand. Once first process done, take that gas cylinder and put it here. Okay, put it here. This is insulating stand. What is the use of insulating stand? Insulating means it does not conduct heat. Yeah, already we are familiar with that concept. So once the cylinder, because it has some amount of heat energy because of this first process. Okay, so this cylinder placed on the insulating stand does not conduct heat energy. That means heat energy does not leave into the system or enter into the system. Yeah, does not enter into the system and does not leave the system because of this instrument. This is the second step. So for adiabatic expansion, now we insulate the cylinder. Okay, insulate the cylinder. So what is the main concept here? No heat can leave or enter. Clear? There's no heat can enter or leave because of this setup, insulating setup. Okay, then what will happen, sir? Already gas expand here, yeah? Piston moves just above, okay? Just upwards, a little bit upwards, okay? Now also the gas continues to expand. The gas now also continues to expand, because once heat leaves the system, heat leaves the system means temperature decreases. So temperature decreases means volume decreases. Yeah, already we know that V is directly proportional to T from the Charles law. Yeah. So temperature decreases means volume decreases. Yeah, volume decreases. But here there is no temperature difference. There is no temperature change. So there is no volume decreases. Yeah, clear. So there is no heat enter or leave. The gas always continues to expand. So this process is called expansion. Clear? Okay. What do you mean by adiabatic expansion, sir? That is no heat exchange. That is called as adiabatic expansion. In adiabatic expansion, what do we called? That is without heat exchange to the surrounding. Surrounding means this is without heat exchange. Okay. So this is called adiabatic expansion. Clear? As it expands, it also does a work. Yeah. Because of that piston moves upwards, like in this case also. So it expands, it does some more work. But temperature drops to T2 or TC. Okay. Why? Because as it expands, it have more area. Yeah. And the temperature drops too, because once the hot reservoir taken out, there is no source to that system. Yeah, there is no heat source to the system, so there is no chances to rise the temperature. So that temperature drops to some low value, that is TC or T2, the temperature of our cold reservoir. That temperature is called as a temperature of our cold reservoir. The engine is still working, but it is cooling down. Okay, it is cooling down, and it has done work done. Okay, okay. This is adiabatic expansion. The cylinder is placed on the insulating stand. The piston is allowed to move out as the gas expands adiabatically. There is no heat exchange. So volume increases. Yeah. So V2 to V3. So for reference, V2 to V3. Because of this denominator, so volume expansion, volume increases. Pressure also change. That is P2 to P3 because volume expansion. Temperature decrease to TL, TC, T2, whatever else. Always denominator as a lower temperature, that is cold reservoir temperature. So this is a adiabatic expansion. Clear? Right. Then we will move into that next process, isothermal compression. Two expansion, two compression process. So all four process included in the Carnot cycle. Next one, isothermal, that is step 3, stage 3, isothermal compression. Isothermal means, already I told you, compression means compressed. Okay. So for this step, from the second step, in that second step, the gas cylinder on the insulating stand. So for the third step, this is sink. Sink means cold reservoir. Okay. This is at low temperature, T2 or TL or TC, cold reservoir, whatever else. Okay. So because it has a temperature which is lower than the hot reservoir, already I told you. So this denoted as low temperature. That cylinder taken out from the second stage and placed on a sink. Now that heat goes into the sink. Yeah. So the heat goes into the sink means volume decreases, because already expanded gas. Now heat decreases, heat passing through the sink, and volume decreases. So volume decreases means piston moves downwards. Yeah. Clear? So this is called compression. Now you are clear with that compression. Yes, yes, sir. Compression. Already I am familiar with concept. Compression. Compression means that heat flows into the sink. Okay, this is stage 3. A gas cylinder placed on the sink. That heat, excessive heat, flowing into that sink. So temperature, volume decreases. Volume decreases means compression. Isothermal means already I told you. Yeah. Okay. Next, we place a cylinder in contact with our cold reservoir, which is at temperature T2, TL, or TC. The gas is compressed. Gas compressed. Okay. It is placed on a cold reservoir. Okay. The gas is compressed isothermally at this lower temperature. Heat is released. Heat released from the gas. And what will happen? Absorbed by the sink or cold reservoir. Okay. It is clear. Gas compressed, heat released. That heat flows into that sink or cold reservoir. The cold reservoir absorb that heat. So now work is done on the gas. In previous step, work is done by the gas. Yeah, by the gas on that piston. But now work is done on the gas. So you have to know the separation difference between the on the by the. Okay, work is done on the gas. Clear? During this compression. Clear? Okay. So the cylinder is placed on the sink or cold reservoir. The gas is compressed, that is isothermally compressed. Volume changes, pressure changes. Okay. So work is done on the gas. So this is a third stage. Next one, fourth stage. That is adiabatic compression. For this fourth step or fourth stage, again take that thermal insulating stand. Okay. Insulating stand. This is a fourth stage. Take that previous gas cylinder position. Okay. So here gas is there. This is stand, thermal insulating stand. Again also cylinder piston moves downwards. Okay. For this stage, this is a setup. Adiabatic compression means finally we insulate the cylinder again and again also compressed happen. Gas compressed here also. Yeah. But in adiabatic, the temperature now increases to high temperature. So from T2 to T1 means from low to high, from cold temperature to hot temperature. Okay. So temperature rises back in this process. Again also work is done on the gas. Work is done on the gas. So work is done on the gas means its internal energy decreases. Suppose work done by the gas means its internal energy decreases. Now that engine now back into the starting state, ready to repeat the cycle. Again, isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression, and then fourth process. For the first process, take out this set of gas cylinder and put it on the surface of a source, that is hot reservoir. Again, process repeats. So we can prove that no engine operating between two given temperature, okay, other than Carnot engine, because Carnot engine operating between the same two temperature. Okay, so now you are all familiar with that, all the process. Okay, it's for the expression or equation. Now, first of all, reversible process means all the process it will repeat itself. Yeah, reversible process in a thermodynamic process can be considered as a reversible process only if possible to trace that path, yeah, in the opposite direction, system surrounding. Okay, so reversible process mean all the process trace that path, that is retraced back in the opposite direction. Suppose one process goes like that, and opposite process also will happen, so which is opposite direction. Yeah, the process that can be retraced back in the opposite direction is called reversible process. Okay, irreversible process. Irreversible process means it cannot be traced back, cannot be retraced back. All the natural processes are irreversible. Yeah, irreversible process means which cannot be retraced, which cannot be plotted in the PV diagram, because in reversible process already we are familiar with the PV diagram, V and P. So in this process, Carnot cycle is there like that. Yeah, but for irreversible process, we cannot plot a PV diagram, because this process cannot have unique values of pressure, temperature at every stage of process. Okay, because one stage at high temperature, another stage is also high temperature and low temperature. So that value does not same or constant, or in other words, it does not have any unique values. Okay, so all the natural process is called as natural irreversible process. Okay, so next one, Carnot engine. Already you may familiar with that now, Carnot engine. So it is a reversible heat engine that operates between that two temperature. Okay, so Carnot engine undergoes a cycle of 4 process, that is known as Carnot cycle. Cycle means that process repeats itself. Okay, right. So Carnot engine has 4 parts. Already I told you, that is source, sink. 4 parts means source, hot reservoir, sink, cold reservoir, and insulating stand, and working substance, that is gas. So the Carnot engine has 4 parts. Okay. So source means which is a hot reservoir. It is a source of heat. It is maintained at a TH. Yeah. High temperature or T1. Any amount of heat can be extracted from it without changing in temperature. Okay. I will repeat that. Any amount of heat can be extracted from it, but without changing its temperature. TH. Sink. It is a cold reservoir, cold body maintained at a constant low temperature, that is TL or T2. It can absorb any amount of heat. So what is the role of sink or cold reservoir? It can absorb any amount of heat. Okay. Insulating stand. Insulating stand, it is made of a perfectly non-conducting material. Non-conducting material. Okay. Heat is not conducted through this stand. Heat is not conducted through this stand. And finally, working instructions, ideal gas. It is an ideal gas enclosed in a cylinder with perfectly non-conducting walls and perfectly conducting bottom. Okay. A non-conducting and frictionless piston is fitted in it already. So this is a non-conducting wall and this is a conducting bottom. This is piston and in between is ideal gas is there. Okay. So all the 4 parts is there. Carnot cycle is there. Okay. Now in we have to calculate what done in every stages now. Okay. Already we have a 4 stages. This is P pressure. This is volume. Okay. Already we have a 4 stages. So first stage here goes and this is known as isothermal expansion. So P1, V1, T1. This is P2, V2, T1. Temperature does not change. So constant temperature means T1, T1, but the pressure changes because expansion. Volume changes, expansion. Okay. Then now this is a second process. This is first, this is second, this is third, this is fourth. So arrow mark is there. Second process goes like there. In second process, adiabatic expansion. Yeah. Adiabatic expansion, the stage at 3, P3, V3, T2. Temperature changes, volume changes, pressure changes. So volume changes means, so here 5, 6, 7, 8. So volume increases. So V2, 6, V3 maybe 8. So volume changes. Pressure. So this is a 10, 9, 8, 7. Okay. So in this stage 10. So for this stage, it maybe 5 or 4. So pressure also changes. So, but it decreases, but it changes. Okay. So P3, V3, T2. And next one, fourth stage. Fourth stage mean, okay, first stage isothermal expansion. Second changes on the adiabatic expansion. This stage, isothermal compression. So isothermal, in our isothermal compression, P3 V3 T2 converts into P4 V4 T2. Temperature is there because of isothermal, but the pressure changes, volume changes. Okay, and final process, adiabatic compression. So adiabatic compression means that process again goes into the previous first stage. So pressure changes, volume changes, temperature T2. T2 converted into high temperature T1. Volume V4 converted into V1 initial stage. V4 converted into P1. So this is the Carnot cycle. For first step, for a first stage, which is like a isothermal expansion, isothermal expansion means that cylinder on the source, gas absorb heat. Yeah. So work is done by the gas in isothermal expansion. Okay. So P1 change P2, V2, V1, V2, T1, T2. Work done W1, which is equal to Q1 because heat is absorbed by the source, that denoted as Q1. Okay, heat is absorbed by the source. So for this, the equation becomes like that, N or T, because this is a gas law, ideal gas law. Yeah, N or T1 logarithm V2 by V1. Okay, this is a work done by the gas in a isothermal expansion. Next one, adiabatic expansion. So in adiabatic expansion, we can remember that the gas is placed on the inserting stand and allowed to expand slowly to its temperature, that is temperature falls to T2. T1 converted into T2. Okay. Work is done by the gas. Yeah. Gas doing some work in a adiabatic expansion. So for this adiabatic expansion, work done denoted as W do, which is equal to NR T1 minus T2 by, so this is a gamma minus 1. Okay, specific heat. This is a work done in the adiabatic expansion. That is from second to third process, stage 2 to stage 3, step 2 to step 3. What the work is P dot dV? From that we can derive this NR by gamma minus 1, T1 minus T2. T1 means high temperature, T2 means low temperature, TL. Okay, right. Then next, isothermal compression. We have to know in every stage process what is the work done, or that equation for work done. Okay, then only we will find that total work done on the 4 cycle process. Okay, so isothermal compression. The gas is now placed in the thermal contact with a sink. The sink at a temperature T2 or low temperature TC or TL. Okay, that cylinder gas compressed slowly. Okay, so the heat produced that heat flowed into that sink, yeah, the gas maintains a constant temperature T2. Okay, the gas releases heat Q2 to sink. Yeah, work done on the gas. W3 is the work done on the gas by the surrounding isothermal compression. So then work done W3 means W is equal to N or T1. First process T1, now T2 logarithm. For this stage, volume is the V3, V4. For first stage, V2 by V1, now V3 by V4. Okay. So this is a third process what done. Then we can move into that fourth process what done. Okay. Fourth process means adiabatic compression. In adiabatic compression, that is in stage 4, the cylinder is positioned on the insulating stand. Yeah, correct. The cylinder positioned on the insulating stand. Okay. Now the gas is further compressed. Slowly it returns to that initial temperature. Okay, it returns to that initial state. Initial state means P1, V1, T1. From P4, V4, T2 to this stage. Okay. So here also work is done on the gas, that is WF4. Okay. It is done on the gas by the adiabatic compression. Clear? So now we can write what done, that is WF4 for this process. As usual, NR T1 minus T2 gamma minus 1. This is a adiabatic compression what done. Okay, now we can write the net what done. Net what done means we have to add all the what done. That is all the 4 stages what done. Okay, net what done for the first stage, for the second stage, for the third stage, for the fourth stage. Okay, but these two process is expansion, these two process compression, which is opposite direction. Yeah, so we can write like this, minus of W3 plus W4. Okay, now you can familiar with that minus sign, because it is which is opposite to the first process. Isothermal expansion, isothermal conversion, adiabatic expansion, adiabatic conversion. Okay, so which is opposite to the previous process, previous cycle, previous step. Okay, so you can recall that in our formula, that is W2 and W4 which is same. Yeah, W2 and W4 which is same, because both are like this. Yeah, which is same. So we can cancel out W2, W4 because which is same. Only changes in the W1 and W3, because W1 V22 by V1, and for W3 which is V3 by V4, and the temperature also changes. Yeah, so we can neglect these two terms. Only W1, W3 is there. Okay. So W means net work done. W1 minus W3 is there. That is for W1 which is heat Q1, for W3 which is heat Q3. Okay, next. For W1, which is nRT1 logarithm V2 by V1 minus of W3 means nRT2 logarithm V3 by V4. Yeah, correct. So now we can we can calculate the efficiency. This is a total work done. Okay, this is a total work done on that Carnot cycle process. The next step, we have to calculate efficiency of the Carnot engine. Okay, so for this we can take this W. Okay, because efficiency means the work done by Q1 input temperature. Okay, input heat. W means nRT1 logarithm V2 by V1 minus nRT2 logarithm V3 V4, which is W divided by Q1. So Q1 means already we know that this is Q1. Yeah, already I told you this is Q1. So we can put nRT1 logarithm V2 by V1 here. This term belongs to both these equations. So we can separate like this. Yeah. We can separate like this because that term belongs to both this equation. So we can write like this. Yeah. Okay. In this process, we can take NR as a common. Okay, NR as a common because NR is there, NR is there, NR is there, NR is there. So we can take it as NR as common and cancel out. Like this. T1 logarithm V2 by V1 and T2 minus of T2 logarithm V3 by V4 by T1 logarithm V2 by V1 and again, so here also T1, yeah, sorry. Sorry. So this time, okay. So here also T1 logarithm V2 by V1, okay. So now you can see that this both term same. So we can cancel. So it becomes as 1. So 1 minus T2 logarithm V3 by V4 by T1 logarithm V2 by V1, which is term. Again also, we can convert it into this adiabatic process. By adiabatic process, V2, which is V2 by V1, which is equivalent to V3 by V4. Because it is separated derivations, which is belongs to adiabatic process. Okay, from that process, you can remember or recall that the previous cases, that is adiabatic. From the adiabatic process, we can prove that like this: V2 by V1 equal to V3 by V4. Okay, so from this we can change into V2 by V1 by V3 by V4. Okay. So now this term and this term will cancel. Only T2 by T1 is there because that term cancel out. Clear? From adiabatic process, that volume V2 by V1 equal to V3 by V4 So we can cancel out. So only T2 by T1 is there. So that is eta, that is efficiency. Finally, we have a efficiency. Eta is equal to 1 minus T2 by T1, which is the efficiency of Carnot engine. Okay, now you are clear with that. All the four process, parts, efficiency, what done on every stages, and reversible, irreversible process. Okay, okay. So now class has finished. Now you can ask any doubts. Any doubt from any school? You can unmute and ask me, or you can chat. Anybody? Anybody is there? Please unmute one student, that is IFP6533 ID number. You can unmute. You can unmute and ask me doubts. Any doubt which is belongs to what is Carnot engine, that is ID IFP6533. Is there? No. Okay. So then APMS Sirim Villa. APMS, you can unmute and ask me doubt. APMS Sirim Villa. Any doubt? Okay. So Carnot engine has four stage: adiabatic expansion, adiabatic compression, isothermal expansion, isothermal compression. It has four parts: source, sink, inserting stand, and the working substance. That means ideal gas and reversible process, irreversible process. Reversible process means we can trace its path. Irreversible process means we cannot trace its path. Yeah. Okay. So Carnot engine is a hypothetical heat engine, which is a, concept, a theoretical concept proposed by the French physicist Sadi Carnot in 1824. Okay. So the Carnot engine is a hypothetical heat engine that operates on the Carnot cycle. It is an idealist engine that converts thermal energy into mechanical work with maximum efficiency. Note that point, with maximum efficiency. Because from that heat engine, we don't have any much of efficiency. Okay, it has some drawbacks. So Carnot engine concept is there. So Carnot engine is a reversible engine, meaning it can operate in both forward direction and reverse direction. Yeah, to forward direction, to reverse direction. Compression, expansion, because compression, which is opposite to the expansion. Yeah. So isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. In all the stages, we know with that work done W1, W2, W3, W4, and finally we calculate that net work done. Okay. So again, and then we calculate the eta, that is efficiency. So which is 1 minus T2 by T1. T2 means that is low temperature, cold reservoir temperature. T1 means that is hot temperature, okay, source temperature. Okay. So this is the efficiency of the Carnot engine. Okay. So now class finished. We can discuss another topic in next class. Thank you. Jai Hind, Jai Bharat, Jai Vidya Shakti.